Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design bandstop filter for RF choke using HFSS software. So before going to the design, what is the function of RF choke? A bandstop filter should function efficiently in a bias network to choke off RF transmission over its stop band, while maintaining a perfect transmission for direct current. So that is the function of RF choke. And basic bias network. What is the bias T network? A bias T is commonly used for feeding DC into active RF components in such a way that RF behavior is not affected at all by the DC connection. So bandstop filters are more effective as RF choke than low pass filters. So due to the limited frequency band of RF active components. And this is the layout of the microstrip bias T incorporating a bandstop filter for RF choke. And the design parameters of the design parameters on the bandstop filter with radial bias stubs. The radius R0. So this is the radius R0. Now the radius is 5 mm. The radius R0 of a radial stub decides the center frequency of the stop band, and the angle alpha is equal to 90 degrees of a radial stub affects the bandwidth. The width W suffix I, the width, now the width is 0.3. So the width can affect on both the center frequency and bandwidth. So now here the bandstop filters from A to B. The point A to B is the bandstop filter for RF signal. So now open HFSS software. And this is 20 mm. And now here the length and width of the substrate I am considering. So this is 20 mm and this is 30 mm. And this width is 1.1 mm. So now here in this design I am considering material Rogers RT doride and its dielectric constant is 10.2, and consider the height of the substrate is 1.27 mm. Consider the band of the frequencies from 3.5 GHz to 5.5 GHz. So using this frequency range, using microstrip online calculator, calculate the width of the line. The width of the line is 1.1. So this is 1.1. So now open HFSS software. First draw the substrate. Select the box. Draw the box anywhere in the plane. Give the rename of this box. This is substrate. And select the type of the material. So now here I selected Rogers RT doride 6006, Rogers RT doride 6010, and its dielectric constant is 10.2. So now change the dimensions of the substrate. X size is 30 mm and Y size is 20 mm, and height of the substrate is 1.27 minus 1.27, and position. X position value is half of the X size value before indicate negative sign, and Y position value half of the Y size value before indicate negative sign. Z position is 0 mm. Click OK button. So this is substrate. So below the substrate we can design ground plane. Select the rectangular sheet. Draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is ground plane. So the length and width of the ground plane is same as that of the length and width of the substrate. So now where the ground plane jet portion is minus 1.27. The height of the substrate is 1.27. So that ground plane is below the substrate. So the jet portion is minus 1.27 mm. And this is ground plane. On the top of the ground plane is substrate. So on the top of the substrate, we can design microstrip bias T incorporating a bandstop filter for RF choke. First draw the main transmission line, select the rectangular sheet, draw the rectangular sheet anywhere in the plane and change the dimensions of this rectangular sheet. So now here axis is the Z axis and X size is that width of the line is 1.1 and Y size is 20 mm and this is Y axis and this width is 20 mm. So Y size is 20 mm and X portion 8 mm and Y position half of the Y size value before indicating negative sign. Z position is 0. Click OK button. And after that draw this line. So now select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So change the dimensions of this sheet. Axis is the Z axis and this length is 23 mm and Y size and width of this sheet is 0.3 and the position X position value is minus 15 mm and Y position value is half of the Y size value before indicate negative sign. So minus 0.3 by 2. Z position is 0. So click OK button. And after that design bandstop filter from point A to point B. So this is point A. Consider the point B. And the spacing between the stub is lambda g by 4 where lambda g is the guided wavelength. So now the spacing is 6.5. So select rectangular polygon, click anywhere in the plane. So now here I am selecting number of segments are 3 and change the dimensions of this polygon. And the center portion 1.5 and the spacing is 6.5 lambda g by 4 distance and the position is 1.5 minus 0.3 by 2. Z portion is 0 and the starting portion over here 1.5 0.3 0.5, and this okay radius is minus 2.5. And now select this rectangular sheet using control button, this rectangular sheet, this choke and this choke. So click Unite button. Now assign perfect electric boundary. So click this unique element and ground plane. Right click on that position. Go to assign boundary. Select perfect E boundary. Now assign lumped port excitations. First to draw the rectangular ports, and this is x-axis and z-axis, and select xz plane. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So this give the rename of this rectangular sheet. This is port 1. And change the dimensions of the port 1, and x size is 1.1 and z size is minus 1.27. Copy paste this rectangular sheet, and assign lumped port excitation of this port 1. Select port 1, right click on port 1, go to lumped port, draw the new line integration from lower port to the upper port. Successfully defined. Click finish button. So this is port 1 lumped port excitation. And rotate the structure. Assign lumped port excitation of port 2. Select port 2, right click on port 2, go to assign excitation, select lumped port, draw the new line integration from lower port to upper port. Successfully defined. Click finish button. And assign lumped port excitation of port 3. This is port 3. And this is y axis, this is z axis. Now select YZ plane. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. Give the rename of this one, this is port 3. So now change the dimensions of the port 3, and this width is 0.3 and Z size is 1.27 minus 1.27. Select this port 3, right click on the port 3, go to assign excitation, select lumped port. So draw the new line integration from lower port to upper port. Successfully defined. Click finish button. So now coming back to XY plane. Give the analysis setup. Go to the simulation. So now here the frequency band is, it is operating between from 3.5 GHz to 5.5 GHz. I am selecting 4.5 GHz, between 4.5 GHz. Ranges from 3.5 GHz to 5.5 GHz. So maximum number of passes are 12. Sweep type is fast and starting frequencies I am selecting 3 GHz and ending frequencies 6 GHz. So points are 101. Now create the open region boundary. Go to the model, right click on the model, select create open region, click OK button. So now check the design validation. So design is successfully validated, and now start the simulation. Simulation is completed. Next observe the response curves. So now here there are 3 ports. So selecting S parameter S11, S21, S31 in decibel. S11 is the return loss plot. S21 and S31 are the insertion loss plots. So this red color curve is return loss plot, and this color green color and this color S21 and S31 curves are the insertion loss curves. So now here we can observe that the curve S31. So for the desired band of frequency 3.5 GHz to 5.5 GHz, showing a good RF stroke for the desired band of frequency.